Hey there, students. Mr. Pilcher here. We are going to start our first notes for Unit 5 on the periodic table. So you want to go ahead and get out your periodic tables right now and your Unit 5 packet. Take a look at this joke. The element of surprise. Do you guys get it? Isn't that funny? That's not a real element. I just made that up. Actually, I stole that joke. Okay, good talk. But yeah, so we're going to talk about the periodic table today. So make sure you have your Unit 5 packet out and your periodic table. Alrighty. So what does periodic mean? So some of you guys might think like, oh, that's some dead guy's last name, which is a really good guess because most things that have some sort of fancy name to them are just some dead guy's last name. But periodic actually has a meaning. Periodic means, and you'll definitely want to write this down, having a regular repeating pattern. Having a regular repeating pattern. Okay, so this is a big idea for all of Unit 5. So on the periodic table, you'll see a lot of different patterns, and you'll see them kind of repeat themselves as you go throughout the table. So there's a lot of patterns, a lot of trends, and they'll repeat themselves kind of over and over as you go through the table. So this is a big idea. So this is basically a regular repeating pattern table is what we're really looking at here. All right. Now, who is the old dead guy who is credited with this? That would be Dmitry Mendeleev. He's this Russian guy, Dmitry Mendeleev. In fact, if you go to Russia, lots of times instead of saying the periodic table, it'll say Mendeleev's table. If you're looking at a periodic table in Russia. No joke. That's real. So Dmitry Mendeleev, he was working on this around 1869. I don't really care that much if you know that exact date, but just know it's like 150-ish years ago. And so he's credited for coming up with the periodic table. That's the idea. Here's what his table kind of looked like. Okay, obviously you don't have to draw his table. So he sort of organized all the elements by atomic mass. He organized all the elements by atomic mass. And one thing that he did that was really impressive was, so take a look at zinc. That's element number 30. And then, so we have zinc right here. Arsenic, which is element number 33, he has right here. And so we know that there are two elements in between zinc and arsenic because they're elements 30 and 33. But back then, those elements haven't been discovered yet. But he predicted that there would be a couple new elements discovered in between these two. Like he made that prediction, and he even predicted what their masses would probably be close to. It's like, oh, they'll be 68 and 70. And so as time's gone on, we've discovered gallium, which has an atomic mass of 70, and germanium, which has an atomic mass of 73. So he's a team off on the masses, but those are pretty good guesses for elements that no one had even discovered before. Something similar happened over here. After calcium, we had never discovered element 21, scandium, but he predicted that his mass would be 45, which is really crazy. So Dmitry Mendeleev's table, it wasn't perfect, but it was pretty good. I mean, the fact that he was able to predict elements that didn't even exist yet, that they would be discovered, is really impressive. Now, you will notice if you look at your periodic table, almost all the elements are in order of atomic mass, but not literally all of them. So for example, if you find argon, which is element 18 on your periodic table, it has a mass of 39.9, but potassium, element 19, the very next one, has a mass of 39.1. So potassium's mass is actually a little bit lower than argon's. So that's one example where the periodic table has the elements not in the exact order of atomic mass, but about 95% of the time, they're in order of atomic mass as well as atomic number. So Mendeleev's table wasn't perfect, but it was most of the way there, which is why he's given the credit for coming up with the periodic table. And he was also arranging elements based on their properties as well. So he arranged them by increasing atomic mass, like I already mentioned. But he also was kind of noticing patterns. So you'll notice he put all these guys here on the left together because they had a lot of similar properties. All right. So let's go ahead and move on. So periodic law, what is that? So that is when properties of elements change with increasing atomic number in a periodic way. So properties of elements change with increasing atomic number. So again, atomic number is the number of protons, slightly different than the atomic mass, in a periodic way. So basically, you'll see the properties as you go from left to right on the periodic table, as the atomic number goes up. You will see elements change as you go from left to right, but they will have repeating patterns as you go from left to right, up and down. So for example, now you don't have to draw any of this or write any of this down, but as we get into the periodic table, you'll notice that there's all kinds of different trends. So as I go left to right here, so we have a shiny explosive metal, and then a shiny metal, and then kind of a shiny metal, and then more of a non-metal, 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 inert gas, boom. All of a sudden, if I go down a row, I'm back to a shiny explosive metal again. Then a bunch of metals, and a bunch of metals, and then some non-metals, and some non-metals, and then some inert gas again. And then boom, back to a shiny explosive metal. Then a bunch of shiny metals, and then they're not so shiny anymore. And then we have a non-metal, then we have an inert gas. And so you kind of see how the elements will change as you go across the periodic table, but you'll see a pattern kind of emerge. So we had a shiny explosive metal, bunch of stuff, then another shiny explosive metal, bunch of stuff, then another shiny explosive metal, then a bunch of stuff. So that is what we're talking about with periodic law, is that you'll kind of see these patterns repeat every so often. And we're going to talk about stuff like electronegativity, ionization energy, all this stuff. You don't have to worry about that right now. There are a lot of different trends that we can find on the periodic table. All right, so now we got to talk a little bit about organization here. So we got to talk about groups. What does it mean when we're talking about groups on the periodic table? Groups are vertical columns, okay? So any element or any elements that are in the same column are part of the same group. And those elements are in the same vertical column. They have really similar physical and chemical properties. So they have really similar physical and chemical properties. And we're going to number those 1A, 2A, 3A. These are Roman numerals. So the little I, that's actually number 1, 2A. So we're going to go ahead, go to your periodic table. And let's number these real quick. So again, here's the periodic table you guys colored already. So again, my colors are greens are metals, yellows are non-metals. It's kind of bluish, purplish, whatever, are metalloids. So we're going to number these groups. So this is group 1A right here. This is group 2A right there. Now we're going to sort of skip this gap right here. I'll explain more about that later, but we're going to go ahead and skip this gap. So group 3A, so boron is the first member of group 3A. Over here we have group 4A. So IV is a Roman numeral for 4. VA, this is group 5, okay? So the letter V means 5 in Roman numerals. So IV means 5 minus 1. V just means 5. VI means 5 plus 1. So group 3, group 4, group 5, group 6. Here's group 7, and here's group 8, okay? And so in any one of these columns, so for example, group 8, all these elements in group 8, they have really similar chemical and physical properties. And same with the folks over in group 1 or group 2. All these elements, for the most part, have really similar chemical and physical properties. All right, so that's going vertically, but what about horizontally? Those are called periods. So periods are horizontal rows. So any elements that are in the same row are said to be in the same period. And so periods follow regular repeating patterns. So elements in the same period are not really that similar. But if you go through period 2, okay, you'll end with an inert gas. And then if you go down and go through period 3, that will also end in an inert gas. Period 4 ends in an inert gas. And so you'll notice that periods have these regular repeating patterns. And we just number those 1, 2, 3, all the way down to 7. So if you go back to your periodic table here, so this is period 1, this is period 2, 3, 4, 5, 6, and 7. Okay, so potassium here, element K, that's in period 4. So just real quick, just to make sure everyone's really clear, you don't have to write this part down. But let's say I was looking for the element, I'll just make this up, in group 6, period 2. What element am I talking about? Okay, so group 6, so here's 1, 2, 3, 4, 5, 6. And period 2, so that's the second row. So, okay, so that would be oxygen. I'm talking about oxygen when I say group 6, period 2. Now, if I said group 2, period 6, so here's group 2, here's period 6, that would be barium, okay? So just to give you guys some clarity, we're talking about groups and periods. And just a reminder, groups have similar properties, periods have repeating patterns. All right, so you'll definitely want to make sure you have the period numbers and the group numbers labeled on your like fancy periodic table with all the information. Okay? Now, you colored yesterday the metals, nonmetals, and metalloids. So let's talk about what metals are, what nonmetals are, and what metalloids are. So what on my demo table is metal? How do you know? So we look at this. Normally, I'd be looking at my sink faucet. Some of you guys can see that behind me. How do you know if my sink faucet is metal? Well, some people are like, well, it's shiny. It doesn't change shape on you. Your sink faucet has the same shape every day. The faucet is kind of hard. Like I couldn't like bend the faucet very easily. Or I should say you couldn't really break it very easily. So you guys already have kind of an idea what metals are. So here are some characteristics. Not all metals share these characteristics, but most metals share these characteristics. So most metals are good conductors, so they're good at transferring heat, and they're also good at transferring electricity. They're usually shiny. They're usually malleable, which means you can bend them without breaking them. So like you can take a metal wire and you can usually bend it without breaking it. And ductile or ductile, however you want to pronounce that, that means you can kind of stretch them. So those are common characteristics of metals. So not every single metal is a good conductor, but most are. Now, most metals also give away electrons really easily. So we'll learn a little bit more why they do this, but for right now, suffice it to say that most metals are looking to get rid of a couple of electrons or so. Okay, so they give their electrons away really easily. So everybody, now don't draw this red line on your nice little periodic table, but generally speaking, the elements under this big curve here tend to give away their electrons, and if they're giving away their electrons, they tend to be positively charged, okay? So any of these metals, so titanium or copper or cesium, all these different metals, they tend to be cations in nature because they usually give away an electron or two or sometimes even three. One question I want you guys to know the answer to real quick, by the way. Let me point something out to you. You will notice, so if we look at cesium, element number 55, right here. Okay. You'll notice that next to it is 56, then 57, and then all of a sudden, 72. And so people are like, wait, whoa, what the heck? What's going on here? Where's element 58 through 71? Those guys are actually down here. So here's where they are. So these elements, 58 through 71, they actually belong, they should go right here in between elements 57 and 72. The only reason they don't is because you see how long this section is. That would make the periodic table like twice as wide, and it doesn't fit on pieces of paper very well. So that's really like the only reason why we do that is so the periodic table isn't like twice as wide. You'll notice the same thing happens the row below. So you have 89 here, and then you have 104 here. Where elements 90 and through 103, they're right here. Okay, so these two rows actually belong here and here. We just pulled them down below because the periodic table would be way too wide. So just an FYI, that's what the deal is there. And you know, this first row right here below the periodic table, we call that the lanthanide series because element 57 is lanthanum. Okay, lanthanum. I don't know how to pronounce it exactly. There's a little bit of debate there in the scientific community. But anyways, in case you ever wonder about that, you're like, wait, what's going on there? That's what's going on there. Okay, so that's metals. You need to definitely know they give away electrons and like to be positive. They're good conductors, shiny, malleable, all that good stuff. Now, nonmetals, they're poor conductors. They don't really transfer heat or electricity very well. They're usually dull, and they're usually pretty brittle. So with a metal, if you try and bend it, you usually can without breaking it. But with a nonmetal, if you try and bend a nonmetal, it like lots of times will just snap, just like that. Non-metals take electrons from other elements. So metals give electrons away, but non-metals love to take electrons from other elements. They like to take electrons, which of course means they're typically going to be negative. Okay, so everything under this blue line, again, don't draw this on your pretty little periodic table, but generally speaking, most of the stuff under this blue curve here, that's where most of the non-metals are, they tend to take electrons from other elements. So fluorine, for example, is a lot more likely to take an electron from an element than, let's say, lithium, who's a metal all the way over here. Okay? So non-metals, poor conductors, dull, brittle, they're not shiny, they don't conduct well, you can't bend them without breaking them, and they usually take electrons instead of giving electrons away, which means they're going to be negative most of the time. Anions. And metalloids, as you kind of guessed, are sort of like metals, sort of like non-metals. They're kind of like the middle child here. Some of you guys hear the middle children are like, oh, salty. So they have properties of both metals and non-metals. They're kind of in between. And they're on the staircase of your periodic table. So this, you'll notice your periodic tables probably have a little bolden line right here. So staircase, boom, boom. So it starts right underneath boron. So we go across, down, across, down, across, down, across, down, across. You'll notice that all the metalloids are touching two sides of that staircase. The only elements that are touching two sides of the staircase that aren't actually metalloids are aluminum and polonium. It's actually a little bit of debate about polonium, especially whether it's a metalloid or not. In this class, we're going to say it's not. So all 5 elements that are sitting on top of the staircase are metalloids, and then germanium and antimony are also metalloids, according to how we are going to label them in this class. These are metalloids, and so stuff like silicon, it's sort of like a metal, it's sort of like a non-metal, depending on how you're looking at it. That's why silicon's actually super valuable and important in computers, for example, so like silicon chips and that kind of thing. But it can also be used in like surgery. So it's really versatile because it's a metalloid. And so a lot of people dedicate their whole careers to studying metalloids because they can be very valuable because of how versatile they are. So those are metalloids. Don't forget about that staircase. So now we're going to talk about groups to know. So groups, those vertical columns, some groups are more famous than others. Some groups are more famous than others. So I'm going to talk to you about characteristics of the famous groups that you'll want to know. And some of these might be a little familiar to you. So group 1A, that group on the far left of your periodic table, those are called alkali metals, and they are very reactive. They are really, really reactive. So the alkali metals we have at school, they're behind a locked, they're in a locked cabinet, behind a locked door, behind a locked door. We have to keep those really safe. They're stored in mineral oil, so they can't even interact with the air around them because they're so reactive. So alkali metals are really, really reactive. That's their sort of characteristic. Now, right next door to them, group 2, those are called the alkaline. So there's an Ne at the end of this. Earth metals. They're reactive. They're not as reactive as alkali metals, but they're pretty reactive. So these are the elements like beryllium, magnesium, calcium. The transition metals, that's from the metals to the non-metals, okay? So I'll come back to the screen here in a second. So the transition metals, when I'm talking about transition metals, I'm talking about this section right here. So all the folks underneath this little blue section here, these are the transition metals. They're in between the metals and the non-metals over here. And so that as you go from left to right, these metals are becoming less and less metallic and more like non-metals as you go from left to right. So scandium has a lot more common metallic properties than something like gallium, which is pretty close to the non-metal section. So when I say non-metals, that's what I'm talking about. Rare earth metals are elements 94 or after element 94, and they're man-made. So I'm talking about, again, I'll come back to the screen. I'm talking about these guys right here. So we usually just label most of these rare earth metals right here, but especially 94 and after are man-made. But so in this blue section down below, those are your rare earth metals. Halogens, this is group 7A. This is on the far right now. That's the second to last column on the far right. They are very reactive. Most of them are, well, they're all nonmetals. Most of them are gases, but they're very, very reactive, just like the alkali metals. And then lastly, the noble gases, they're group 8. They're the far right column of the periodic table. They are inert, which I actually mentioned this word earlier in class today, which means they don't react. So helium, for example, does not react with like anything, and neon doesn't really react, and argon doesn't really react. So noble gases are known for being gases, of course, and not really reacting with anything. Not really reacting with anything. Now, you need to know these 6 different sections on the periodic table, okay? So group 1 and 2A are called alkali metals and alkaline earth metals. You need to know the transition metals are the gap between the metals and the nonmetals. You need to know the rare earth metals are all the elements below the periodic table. You need to know halogens. You need to know noble gases. You need to know their general characteristics. Okay, so those are things you actually need to know for your quiz on Friday. Now, if you go ahead and turn to one of your blank periodic tables, so not your fancy one, one of your blank ones that's in your packet, so they look just like this right here. We're going to go ahead and do some labeling on this guy. So I have the element boxes are empty, so we can kind of write throughout the boxes to help you. So if I have my group numbers here again, boom, 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 here we go. So don't forget that metals give electrons, okay? So we're going to kind of review everything we just did. Don't forget that nonmetals over in this general area take electrons. And now let's go ahead and label all the groups and sections we were just talking about. So here are, well, here are your period numbers on the far left. And then here are your alkali metals right there, okay? So this whole column, I think you should write vertically alkali metals. By the way, so this is the part of it where you might want to pause for like 10 or 15 seconds if you need a little extra time to label, if you want to make sure things are nice and clean labeled. But you don't have to. Here are the alkaline earth metals. Here are the transition metals, this whole big section. Here are the metalloids right there. So in this general area where the staircase is. Here are your halogens. Here are your noble gases. And then this whole section down below, these are your rare earth metals. Okay? Now, you may remember that I mentioned earlier that these groups, so with the Roman numerals, these are the A groups. The B groups are down here. So the whole transition metals, they have B group numbers. We're not going to really worry about those for now, but you might notice how they have their own group numbers, but those are the B system. We really just care about the A system, where this is 1, this is 2, 3, 4, 5, 6, 7, and 8. So there's that. And again, I like this little drawing here. So groups are going vertically, periods are going horizontally. Groups have similar chemical and physical properties. Periods have those regular repeating patterns, okay? So this blank periodic table here, I think, should be really helpful for you in terms of being able to see all your labeling. You do need to know where the alkali metals are. So if I ask you, hey, what family, or I could say family or group, mean the same thing. What family or group is sodium in? So sodium, if you look at your normal periodic table, is right here. It's this box. So you'd be like, oh, that's an alkali metal. I was like, what family is fluorine in? So this is fluorine over here. It's this box. And so you say, oh, fluorine must be a halogen. Okay? And so you could also say fluorine it's probably a nonmetal. It probably takes electrons. It's probably brittle. It's probably not a conductor, all that stuff, because you know fluorine's a nonmetal and it's part of the halogens. All right. So let's get to our last slide here. This is really easy. I'm about to say a stupid, made-up Mr. Pilcher word like a million times, so get ready to be annoyed. Oh, yeah. So you won't really know why this is important yet, but this will be a really helpful little acronym for you down the road. So some atoms will never be found alone in nature. So these are called diatomic elements. So di means 2. Atomic is referring to atoms. So these are 2 atom elements. So for example, oxygen gas that we breathe in all the time, it's not O. So the formula for oxygen gas is not O. It's actually O2. It's always two oxygens bonded to each other. So oxygen atoms don't like to be alone. So they always get stuck to another oxygen atom. They always form a chemical bond. And so diatomic elements are atoms that will bond with each other to be stable. So there are 7 elements that you need to memorize here. So like I said, you'll never find oxygen by itself in nature. And here they are. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These are the 7 elements. And so they will always be found as H2, O2, F2, so on and so forth, if they're alone. Okay, so you'll never find a bunch of hydrogen atoms individually floating around. They'll always be attached to another hydrogen atom. There's no one else to play with, so to speak, in terms of elements. Now here's a really fun way to memorize this. These 7 elements can be memorized with the acronym Hofbrinkel. Hofbrinkel. Like, I'm going to Hofbrinkel this test right now. I swear to Hofbrinkel, I will Hofbrinkel you if you don't Hofbrinkel a Hofbrinkel. Hofbrinkel, 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 Hofbrinkel. Hopefully, that's now burned into your mind forever and ever. Oh, there's Miss Maddie. She's probably gonna say Hofbrinkel. I can tell. She's gonna say it. Oh, she just forgot. Well, you know, she'll say it later. I'm sure she'll announce it later. Hofbrinkel, 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 Hofbrinkel. Okay? All right, so make sure you guys get ready to Hofbrinkel that quiz on Friday, right? And don't forget your surveys. Okay, all right. Good talk. Bye-bye.